Hello, statisticians. Mr. Youngsaver here from Skew the Script. Today we're going to talk about who was the greatest of all time, the GOAT in the NBA in terms of scoring. LeBron, Michael Jordan, or Wilt Chamberlain. To do so, we're going to be talking about Z-Scores, percentiles, and cumulative frequency. Let's skew it. Today's lesson marks the start of our second unit, talking about location within data distributions. And today's lesson is about percentiles and Z-scores. It is the first lesson of Unit 2 in our sequence. Today, the key question is among LeBron, Jordan, and Wilt Chamberlain, three of the all-time greats of the NBA, who was really the greatest of all time in terms of scoring, who was the GOAT. So, if you want to follow along, go to the guided notes that are linked here at the Skew the Script website, print it out, and follow along with us. We're going to start today with talking about percentiles. So we're going to start by talking about me. Here's a picture of me from high school. And of course, the great Guy Fieri. I love talking about Guy Fieri. He's one of my favorite celebrities. And he is known for best for being the mayor of Flavortown. And we're going to talk about who did better on their SAT, me or Guy Fieri. Well, on my SAT, this is one of my actual SAT score, but say this was, I got 1050 out of 1600. Back when I took it was out of 2400. Say this was my score on the SAT. And unfortunately, they don't offer the SAT in Flavortown, USA, where Guy Fieri is from. So instead, he took the ACT. And his ACT score was 23 out of 36 possible points on the ACT. So Flavortown College wants to select one of us as a student at its school. Who should select? Me with an SAT score of 1050 or Guy Fieri with an ACT score of 23? Well, if we do some very simple math, let's say 1050 out of 1600 possible points on the SAT is 66%, 23 out of 36 possible points on the ACT is 64%. So maybe I'm a little bit better because I got a higher percentage of the points possible. But unfortunately, it's just not that simple. These tests use different metrics for scoring, different scales, different ways of weighting questions and sections. This is not the proper way to compare these distributions. So how can they be compared? Well, we can use a concept called percentiles. Percentiles are data below a certain value. So for example, we're going to look back at the salary data set we looked at in Unit 1. At what percentile is a person who makes a salary of $43,000 among all these salaries, and this is in thousands of dollars. So $43,000 is above 9 of the data points. It's above 9 out of these 12 data points. You can see the 43 here is above 9 of them. So the amount of data below it is 9 out of 12, which is 75% of the data. 75% of the data is below 43,000. That is its percentiles. The salary of $40,000, and this is key phrasing, is at, make sure you use the word at, is at the 75th percentile of salaries. We can apply this concept of the percentiles to box plots, which we also looked at in our last lesson. Quartile 1 for box plots generally is at the 25th percentile. 25% of the data values is below the first quartile, so it makes it the first quarter of your data. 50% of the data values are below the median, in this case 6 out of 12 for our salary data set. 75% of the values are below quartile 3, and then the highest data value we'll actually talk about later on in the lesson. So who should Flavortown College select? Me or superstar chef Guy Fieri? Well, what percent of people did each test taker in this case outscore? Let's look at the SAT and ACT percentiles, and we can see that a score of 1050 is at the 45th percentile for the SAT, and a score of 23 is at the 69th percentile for the ACT. So that means that I scored above 45% of test takers, and Mr. Fieri scored above 69% of test takers. So that makes it a little bit clearer. Who should Flavortown College select? Well, I was only at the 45th percentile. Mr. Fieri was at the 69th percentile. So it seems like Mr. Fieri's score is the more impressive one. So if all else is equal, that standardized test score is better, they'll select him. So, Mr. Fieri, mayor of Flavortown, he's going to go to Flavortown College. Let's be honest. Now let's talk about something called cumulative relative frequency. This doesn't come up all the time on the AP exam, but it is something important to know. So cumulative relative frequency charts look like this. And whenever you see one, you can take that y-axis and replace the word cumulative frequency with percentile. Cumulative frequency and percentile if it's a relative cumulative frequency, are essentially the same thing. And we can use a curve like this, which in this case is the ACT scores and the percentiles, to determine how good scores are. For example, is an ACT score of 18 a good score? Well, let's look at the ACT score of 18 on the x-axis here. We draw a line up, and we can draw across to find the percentile, which is 40%. So in this case, we know the ACT score of 18 is at the 40th percentile. So if you score 18, you're above 40% of ACT test takers. So it's okay. It's an okay score. It's not better than half, but it's okay. So you're applying to an elite college, and you want to score in the top quartile of test takers. What score would you need? So to be in the top quartile, it means you need to be in the top 25%, which means that you need to be in the 75th percentile. You're above 75% of people. So we can draw a line from the 75th percentile and then draw down to find what ACT score that corresponds to. That corresponds roughly to a score of 24. So you need a score of 24, which is the third quartile, 75th percentile, to be in the top 25% of ACT test takers. Now let's get to the meat of what we're looking at today, standardized scores, or Z-scores, to analyze our key question. Z-scores measure how many standard deviations a data point is above or below a mean. So this is the formula for a Z-score. We're going to go through it. You essentially take the data point's value, you subtract the mean from it, and you divide that whole thing by the standard deviation. In our notation, it looks like this. So let's look at this example. Who was the best scorer? LeBron, who played most of his career in the 2010 era, Jordan, who played most of his career in the 90s, and Wilt Chamberlain, who played most of his career in the 1960s. LeBron also played a lot in the early 2000s, but his best years were in the 2010s. So right now, if we look at the best scorer, if you look at their career statistics, Jordan's and Wilt's points per game, that's what PPG stands for, points per game, is the highest at 30.1 points per game. They averaged over 30 points per game in their careers, which is really impressive. And LeBron, 27.1 points per game, also really impressive, but not quite as impressive. But we need to take into account these players played in different eras. And we need to think about the league might have been different. There might have been times where it was more defensive, more offensive. There might have been times where rules were changed, etc. So who's the best relative to their time, to the peers that play in the league at their time? So we can look at the average points per game for players in that era. In the 60s NBA, the average player scored 10.8 points per game. In the 90s, that was 8.7 points per game. And in the 2010s, it was 8.4 points per game. So we can take their points per game and subtract it from the average in their area. And that difference gives us a sense of how much better they were than the player in their era. Wilt scored 19.3 more points per game than the average player during his career. Jordan, 21.4, and LeBron, 18.7. So that kind of differentiates Jordan and Wilt a little bit. And we can see now here's the power rankings. But we need to also consider variability. Here's why. So say there's two leagues, League A and League B. In both leagues, the average amount of points per game is 10. The average player scores 10 points per game. But in League A, the standard deviation of points per game, so the typical distance from the mean, was about 2. So the typical distance from the mean points per game is about 2 points per game. In B, that standard deviation is going to be 4. It has more variability, more variation. That's why we see the difference in these data distributions here. So let's take a player, and this is actually me. And as you can see, I'm extremely athletic. Let's zoom in to see how athletic I am. Yeah, very athletic looking there. And say I score 14 points per game. I'm better than average. And so that's 4 points per game better than the average. Now, in League A, that means that I am 2 standard deviations above the mean. 2 times 2 is 4. But in League B, I'm only 1 standard deviation above the mean. What that means is, in League A, there's going to be fewer players who are above me in terms of points per game. Because there's less variation, that means there's more players around that mean of 10. So I am more unusually high in my points scored per game, so there's going to be less players who are above me. Whereas in a league with more variation, there's going to be more spread on the upper side of that tail, and I'm only going to be better than most players, but there's still 16% of players that might be better than me if we're assuming a normal curve here, which we'll get into in a later lesson. But the idea is, if there's more variability, my score, even though it's 4 points per game higher in both leagues, is going to be less unusually high because there's more variability. So we need to talk about standardization. When you standardize a point, that means you're getting the points location distribution and you're scaling it by both its distance from the center and accounting for the distribution spread or variation. So let's talk about standardizing these values. Let's look at those differences from the mean, and we see those differences here. But now let's talk about the standard deviation of the era. In Wilt's league, the standard deviation was about 7 points per game. So the typical distance from the mean number of points per game for players in the 60s NBA was about 7. In Jordan, that was 5.9. In LeBron's era, 5.5. So we can find the Z-score, which is the number of standard deviations away from the mean. We had the formula for that earlier. And that formula, remember, is the data point, their points per game, minus the mean number of points per game for the error, divided by the standard deviation for the error. That's going to give us the number of standard deviations higher than the mean that they were, because we're taking that difference and then scaling it by the standard deviation for the error. So when we do that, we start to notice that in leagues where the distribution was tighter, where there was less variability, such as LeBron's era, he is more standard deviations away from the mean than Wilt, where there was more spread. So there might have been some people above in terms of points per game. So in this case, we can see if we standardize that Jordan was 3.6 standard deviations above the mean, which is ridiculous. That means he is really unusually a high scorer for the 90s era NBA. LeBron was actually in a close second with 3.4 standard deviations above the mean for his time. And actually Wilt, who started out on top with Jordan, now that we see there was more variation in his time, actually comes out behind with 2.8 standard deviations above the mean. Still really good, still unusually high, but not as much standard deviations away from the mean as Jordan or LeBron. Now, let's talk about a not so great player, Adam Morrison. So Adam Morrison used to play for the Lakers. He played in the 2009 season for the Lakers. I grew up watching the Lakers and I love them. And he played in that season for only 44 minutes. He sat on the bench the vast majority of the time. To put that in perspective, Pau Gasol, one of the all-stars on the team, played almost 3,000 minutes, and so did Kobe Bryant, again, all-star on that team. People always say I look a lot like Pau Gasol. I don't see it myself, but there's a little comparison picture if you'd like. Now, let's look at Adam Morrison's points per game, but first let's look at his keyest feature, his most striking feature, which is this incredible mustache. I've never seen a mustache that gruesome before, and it was really striking to watch that as we were watching the games and seeing him on the bench with that mustache. Very intimidating, all the players on the court. So while he was on the Lakers, Adam Morrison averaged 2.2 points per game. The league average was 8.4 points per game with a standard deviation of 5.5. So if we calculate his Z-score, we're going to take his data value, subtract the mean, see how different it is than the mean, and divide by the standard deviation to scale it by the spread. So we do that. When we do the subtraction, we get a negative number, divide that by the standard deviation of 5.5, we get negative 1.1. That negative value means that Adam Morrison's scoring rate was 1.1 standard deviations below the league average, below the league mean in his era. So compare that to, say, LeBron, and you see there's a negative and a positive. We can tell how good, quote unquote, a player is in terms of scoring by if they have a negative Z-score, they're below average, positive, it's above average. So that's what we mean here when we say Z-score is direction, negative. Positive means you're above the mean, negative means you're below the mean. But I might be making fun of Adam Morrison a little bit, but keep in mind, it's all about the bling in the NBA. It's all about your championships. The Lakers in this era won a championship in 2009. They also won one in 2010 with Pau Gasol and Kobe Bryant leading the way. Adam Morrison was on both those teams, so he also got 2 championship rings, even though he sat on the bench most of the time. So that means that Adam Morrison, who averaged 2.2 points per game, has more championship rings than Allen Iverson, who averaged 26.7 points per game in his era, Russell Westbrook, Steve Nash, Harden, Patrick Ewing, who averaged 21 points per game, Chris Paul, Charles Barkley, who averaged 22 points per game, Karl Malone, who averaged 25 points per game, and Jerry West, who is literally the logo of the NBA is shaped after his body. He has more championship rings, Adam Morrison, than all of them combined. So don't diss Adam Morrison just yet. I think he knew what he was doing. Maybe he's the GOAT. You know, maybe it's not Jordan, maybe it's him. So we're going to finish off today with a quick discussion question. You might notice when I was displaying the ACT score percentiles that we never reached 100. The max ACT score of 36 isn't the 100th percentile. Why do you think that is? That is a discussion question that I'm leaving you with today. All right, have a good rest of the day, y'all. Goodbye for now.